Okay, so monomial. I'm just going to read the definition as it says here. A real number, variable, or a product of a real number and one or more variables with whole number exponents. Like, that's just in and of itself confusing. If you were to give this to an LA teacher, they would just destroy you for too many commas. Like, it's just not a very good sentence. So monomial, an example of a monomial would be like 2x. 2 is a monomial. X squared, monomial. One term, right? If you have a binomial, trinomial, or polynomial, those are separated by plus and minus. So 4x squared, monomial. 4x squared plus 2, binomial. 2 terms, binomial. Bicycle, 2 wheels, 2 terms, binomial. So 3 terms would be a tricycle, trinomial, right? And then polynomial has 2 meanings. If we're talking about the number of terms, that means 4 or more. So you could add that to this definition down here. Polynomial is 4 or more terms. It is also like an overarching term. Like real numbers is an overarching term which refers to many types of numbers. Polynomials just like that. What's excluded from polynomials is negative or fractional exponents. Okay, negative or fractional exponents is excluded. So I give them a minute to write those down. Couple pencils still moving. Again, so we got a lot of definitions like this. We make that giant chart. You guys may have seen if you were in here at the beginning. So all kinds of stuff to learn today. We good on this? Okay, so write the stuff below the box here, and we'll talk about the box eventually. If you're talking about standard form of a polynomial, if you don't like this definition, you just write decreasing order by exponent. So if that works for your brain better than the definition up here, decreasing order by exponent works as well. As far as turning points go, how many turning points does this graph here have? X cubed has how many turning points? 2. Turning points are based when the graph changes directions. The number of turning points is always 1 less than the highest degree. So it's x cubed. X cubed has 2 turning points. X to the 4th has 3 turning points. This is a positive x to the 4th. Looks like a W. Has 2 minimums, 1 maximum. They add the term relative when there are 2 of them. So this is a relative minimum, relative minimum, relative maximum. Okay? Relative max, relative max, relative min. So the word relative in this, to me, doesn't really mean a heck of a lot, but they just add that to it. So when you see relative, don't freak out. Just relative min or max. If I think end behavior of a polynomial, I'm envisioning arrows on the end of the function. Okay? Arrows on the end of the function. So if I have a positive quadratic, so positive x squared is going to look like this. If I think about the arrows on the end, I'm either saying up or down. So positive quadratic would be what? Up or down? On the left, it's up, and on the right, it's up. Easy, right? So if I look at a positive quartic, what's the end behavior? Up, up. Negative quartic? Down, down. So you got to say both ends, the left and right end. Okay, this one, positive cubic, down, first up, so left to right, just like we read. This one is up, down. Okay, end behavior is easy, arrows on the end. We're going to talk later about the concept of intervals, which confuses students because they mix them up. So end behavior, arrows on the end. That's a great thing. End behavior in red or some obnoxious color that's going to hurt your eyes, right? Arrows on the end. You're more likely to remember. So they're talking in this box at the top of the page, 4x to the cube, that's a cubic term because it's to the third power. I think of a cube having 3 dimensions. So cubic term, just third power, quadratic term, second power, linear term, first power, constant term doesn't have an x, just the number. Anyone need more time on that? A couple pencils still going. Kaylee?
What was your definition for the top one?
Standard form, decreasing order by exponent. So highest exponent, then next highest, and so on. Good. Keep asking those questions. We good? Anyone? A couple people still writing. This is now my smallest Algebra 2 class, 33 students. I have 34, 35, 33. It's a lot. Yes. Grant switched into my 6th period, giving me the 35th kid. He didn't want to miss 7th for lacrosse all the time. Okay, we good? Okay, you got to write the headings, make the chart, write all the headings. So degree is first, and then I'll scroll it to the right eventually once you start writing that stuff. Name using number of terms is the second one. And then we'll fill this chart out once you're done writing the headings down. So this is another easy thing to mix up, the name using degree and the number of terms. So name using the degree are things like linear, quadratic, cubic, quartic. You're going to learn quintic today, which is 5th degree. Number of terms, 1 term monomial, 2 terms binomial, 3 terms trinomial, 4 terms poly, 5 terms poly, 6 terms poly. Okay, so poly is 4 or more as well. We're going to start here with a degree of 0. Name using the degree is constant. An example is like 3. So the reason that degree is 0 is because we could add in 3x to the 0 power, because anything to the 0 power is what? Not 0, 1. So 3x to the 0 is the same thing as 3 times 1, or just 3. Okay? So that's why 3 times 1 is 3. Ah, so you're thinking because... Say why you think that's the case. But just the x to the 0 is 1, because these are 2 separate things. It's kind of like negative x. You okay? Yeah. But that's a good thing to bring up anyways. I'll just say it real quick. The reason this works is because it's like negative 5 squared versus like negative 5 in parentheses squared. Right? This one means negative 1 times 5 times 5. This one means negative 5 times negative 5. So it's the same kind of concept where the negative only the negative is just by itself. It's kind of like a negative 1. So that's why that kind of makes sense. Number of terms here, it was 3 originally, so that's one term. One term is called a monomial. If I have a degree of 1, does anyone know what it's called? X to the first power is, if you graph something like 2x, what does that graph look like? A line, so it's linear, exactly. Linear. So I'm just going to write like 2x minus 1. How many terms do I have when I write 2x minus 1? 2 terms. What's that called? Binomial. Bicycle 2 wheels, binomial 2 terms. Second degree is quadratic. So then I would have 2x squared plus 2x minus 3. Again, I'm just completely making up these examples. Doesn't matter. Just making sure I hit all the different options. So I have 3 terms there. That is called a trinomial. Third degree is called a cubic. Right? Like I said before, cube has 3 dimensions, cubic 3 as the degree. So we've already, actually, let's do, so I'm going to do 3x cubed plus 2x squared minus x minus 1. How many terms? Called 4 terms, called a polynomial. What a good test question. What are the 2 definitions of polynomial? Right? Polynomial refers to 4 or more terms. Polynomial also refers to essentially any number except those with a fractional or negative exponent. Okay, 4th degree is quartic, 4 quarters in a dollar, quartic. So I'm going to get lazy and just write x to the 4th, 1 term, monomial. And then 5th is quintic, Q-U-I-N-T-I-C, quintic. So x to the 5th, we'll just go plus 2, why not? 2, and then that's going to be a binomial. So next slide, what we're going to do is we're going to have a polynomial. We're going to write it in standard form, and then we're going to name that polynomial by degree and number of terms. Okay? So you could write down A and B, please, and then to write it in standard form, you can do that on your own. I'll be writing it up in a second. Standard form is decreasing order by exponent, so highest exponent first, then next highest, and so on. So, and then if you look at B, you can combine like terms. So when you write it in standard form, you should always combine like terms. Good luck. Okay, so make sure you combine like terms, otherwise you're going to get it wrong. So this first one here, A, I have 9x squared plus 3x plus 5. I'm going to name it by degree number of terms after I write in standard form. So for the B1, I get x to the fourth. Then I have some like terms here. 10x squared minus 6x squared is 4x squared. And then plus 4x minus 12. So this is the kind of test question, like, please don't miss this. So if it helps you to, like, underline things or cross off to make sure you got every little piece, just be careful and do that so you don't make a careless error. So if I name this first one here by degree number of terms, the highest degree is 2. Second degree is called a quadratic. 3 terms is a trinomial. So first one is a quadratic trinomial. So my sixth period student assistant was a student in my class last year. We were talking about this, and she said, but I've never had to use that again. So literally after this quiz and test, you won't have to, like, write it down like this, but I will talk about it. I'll say, all right, we're going to talk about a quadratic trinomial now, and I expect you to know what that means, right? 3 terms, second degree is the highest degree. So you won't use it specifically as far as identification of it, but I'll use it in how I talk about the problems all the time. Okay, so this one, 4th degree, is a quartic and then polynomial. Quartic, polynomial, excellent. Quartic, polynomial. And then write down the got it ones, the A and B, and try it on your own. Standard form, and then name it by degree number of terms. I'll give you a couple of minutes, and then I'll start to write them up here. I'll make this a little bigger so you can see it better. Make sure you combine like terms on the B. Write it down, give it a shot. Decreasing order by exponent, and then name it by degree and number of terms. First one, highest exponent, is x to the fourth, so it should be a quartic trinomial. Second one is what? Quintic trinomial. Excellent. So I'll show you up here how that works if you didn't get that part. So first one, quartic trinomial. Second one, quintic trinomial. Okay, when I post these videos, I will always post it on the calendar on Schoology as a separate kind of link for the day's assignment. And Evan, remind me to get you on Schoology so you can see all that stuff, because I put all the book pages on Schoology so you don't have to check out a book, unless you want to, of course. Okay? All right, so you got to write these 2 equations and graphs. You don't have to be crazy about the graph and make it exact or anything, but I just need that general shape of the graph, because we're going to identify these 2 relative minimums and the relative maximum. And same thing over here, the relative max. And we're going to talk about these intervals now. So if you look at that first one, the end behavior, you're thinking about arrows on the end. So the end behavior of the first one is up, up. Second one, down, down. Okay, end behavior should be really easy. Arrows on the end, no big deal. Turning points for the first one, it's x to the fourth is the highest degree, so you know there are going to be 3 turning points. Number of turning points is always 1 less than the degree, highest degree. That's why the second one only has the 1 turning point. So end behavior on the first is up, up. Second one, down, down. Turning points for the first one is 3. Second one is 1. And now we will talk about the intervals. So intervals is a confusing concept for many students. Hopefully I get better at teaching it so it won't be as hard. With this concept of intervals, critically important that you only use the x values. Okay, so intervals only use x values. As we get into the problem more, it'll make more sense. But for now, just write intervals, only use the x values. So to do this, you can bust out your graphing calculator, and we're going to throw that first equation in there, 4x to the fourth plus x cubed minus x. Throw it into the old graphing calculator, like that. Now I had somebody, I don't remember who it was, didn't know that this x button existed on their calculator. So if you didn't know that, just use this button next time because it's easier. They were doing alpha x before. It works also, but it's easier to hit 1 instead of 2 buttons. Do you need calculator? Okay. Okay, so throw that in there. The only time you want your plots on is when you're entering data. We are not entering data, just a polynomial. So if your plot 1, 2, or 3 are highlighted, just hit enter. Go arrow up to them like this, or not. Hit enter, that's when it's on. When it's highlighted like that, you hit it again, it's no longer highlighted, plots are off. Some of your calculators, depending on how old or new your calculator is, will give you an error message if you leave those plots on. So just make sure you get them off. Throw that equation in there, and we'll get the mins and maxes next. Yeah, so critically important that you guys are doing your homework diligently this semester, especially if you struggled last semester. Coming in for help a bunch if you struggled last semester. Again, if you got an A or B, you might have to work a little bit harder than first semester, but you should be good. But some chapters come easier to you guys than other chapters, so just know if you get into that chapter and you're really struggling, come in for help so I can help you sort through that confusion so you can still get the good grade that you should. All right, so I'm going to hit Zoom 6 to get it to a regular window here. So it's got that W shape, kind of like this x to the fourth does on the old school whiteboard. Okay, now not all x to the fourth look the same. They just generically look like a right side up W, but it depends what else is after the x to the fourth as to how curvy or whatever it is. So you're just kind of getting a general view of what it should look like. Now, I want to zoom in right here so I can see what's going on in this graph better, because I have to get this relative minimum here. So I have to do second trace minimum, left bound, right bound, and if I expand it, it's just easier to handle. So I'm going to do that now. So 2 ways you can zoom in. You can either hit window, and if I look at this graph, I could go from -2 to +1 on the x value. It'll zoom it right in there. I could also, and either one's fine with me, I don't care which one you do, I can also just hit zoom in like that. And then you've got a blinking cursor right there at 0, 0. For some of your calculators, again, depending how old or new, that blinking cursor is like minuscule. You can barely see it. And if you move your arrow left and right, then you may be able to see it a little bit better. But just know it's there. And we're zooming in based on where that cursor is. So it zooms in right there. So I'm just going to move it over a smidge. But it'll work out either way. It's fine. See, now it's nice and spread out, so it makes it much easier to get this min and max. So we're going to go second trace minimum for the first one. So I can either arrow down to number 3 or just hit 3. And then I'm going to move my cursor over to the left side of that minimum. And the right side of the minimum. And my cursor disappeared. Oh, the calculator froze. One second. Try that again. Give me 1 second there. You know, did you see the little yellow thing spinning up here? You know, that happens sometimes, and it's really irritating because it takes forever to graph or sometimes freezes like mine did. If you hit on like I just did, it'll stop the graph. Okay, so it just makes it easier. And then I'm just going to zoom in because that's what I'm going to do next anyways. And then I'm kind of killing 2 birds with one. Of course, it didn't zoom in, but we'll zoom it in here in a second. Calculator's having problems. Okay, so now we're back to it. Gotta wait for the little yellow thing to go away. Second trace 3. So we're just basically trying to surround that minimum. Your calculator may not show the dotted lines, but it doesn't matter. Then it says guess here. We hit enter once more. And our first minimum, I'm going to round to tenths on this, so -1.1, -1. And I'm going to identify that on the graph up here. Now I'm going to get this maximum. So second trace number 4 for that. And I'm just going to surround that maximum. So I get -0.3 and 0.2. And then we'll do the last min, so second trace number 3. So when you're bracketing them, you just have to be on either side, right? My cursor was not at the same level on the min or max or anything. Just as long as I don't go over the hump here, I'm good. So I just have to be kind of in the decreasing part here and then on the increasing part, and I'm good. It'll work. So I get 0.2 and -0.1. 0.2, -0.1. Okay, So when we do these intervals, we're only going to use the x values. Again, I'm envisioning the roller coaster car. So is it increasing or decreasing here? Roller coaster car is going up or downhill? Right here. You have to visualize, right? It's going decreasing and then increasing, then decreasing and increasing. I won't give you these on the test, so you have to know that part as well. I just wrote them down because it'd be easier today. The middle part of these intervals is always going to be the same, less than or equal to x, less than or equal to. So you can just fill that in right off the bat. If on a test you have no clue how to do any other part of this, and you at least do this part, I can at least give you a point. Anything that makes sense. I'm trying to give you points on a test when I grade your tests. We always start now at negative infinity, and we'll talk about that in a second, to positive infinity. So it always begins at negative infinity, goes to positive infinity, unless they specify it's going to go from like -5 to +5. That might happen. So just know that that's a possibility. So why does it start at negative infinity? Again, we're only using x values. If I look at this, I'm just going to change the graph a little bit because it makes the point better. So I just zoomed in on the graph in a slightly different way here. And as I'm looking at this increase in the graph, right, I'm thinking about the x values. As this goes up infinitely, it's going to include every single negative x value. That's why we start at negative infinity. And as this one goes over here, right, we're going to end up at positive infinity. It's going to keep going up and up. And you can always draw a line down to the x-axis. So that's why it starts like that. So we always start with our smallest x value, right? So start with negative infinity, and the first one number part we're going to write is the smallest x value, which is, what's the smallest x value of those max and mins I wrote? Negative what? Negative 1.1, right? Smallest one. I just go with the first x value I did. Second x value, third x value, okay? So negative 1.1, that negative 1.1 repeats. So once you get these intervals down and recognize the pattern of the intervals, it makes it easy. So the next smallest x value is this negative 0.3 here. That repeats. And then the last and highest x value is 0.2. That repeats down here. Right? So they always repeat on the diagonal. And it's always less than or equal to x, less than or equal to in the middle. So once you get that pattern down, these things are pretty easy. But again, don't mix up that end behavior. What's the end behavior of this? It says it right here, up, up, right? Intervals, you're dealing with the x values, where it's increasing and decreasing. So end behavior, arrows on the end. Intervals, think of the roller coaster car. So if you write those two things down, like at the bottom of this slide, that'll help you to keep that sorted out. Because trust me, I've seen lots of students get confused by that. Okay, last thing we're doing today is this here. So we're going to throw that in, negative x squared plus 2x, into the graphing calculator. Oh, geez. What was it? Negative x squared plus 2x. Right, if you're struggling on this stuff already, great time to come in tutor time tomorrow morning, right? Because I shouldn't have that many kids. Of course, I'll have like 40 now. But so we're going to hit zoom 6 to a regular window. We're going to get that maximum, so second trace number 4 to get the maximum, and you should get 1, 1 when you get this maximum, okay? So second trace max, guess, enter once more, 1, 1. So this maximum here is 1, comma 1. So I'm just going to write the less than or equal to x less than or equal to. Just start off writing that. My smallest, I want to always start at negative infinity unless it's specified, to 1, 1 repeats, and then positive infinity. Just a little pattern, that's all. Okay, that is it. Your homework's up there on the board. For you guys, it's due Thursday. You want to come in tomorrow morning for tutor time and do homework? Most of you will probably sleep in. That's what I would do if I were you. But, you know. See. Okay. Thank you.